Hey guys, so today we're going to just get an introduction to electron configuration. This whole unit is about electrons. However, we are going to focus on electron configuration, and you'll need that periodic table that I gave you in class that just has just the really simple, just the symbols and not the other information. Get that out, okay? In addition to that, I need you to get out a piece of paper for your notes, because you're going to add some information into your notes, and I'm going to be very specific as to when something goes on the periodic table and when something goes in the notes. There will also be times when I'll say, put your pen or pencil down and just watch what I'm doing so that you can kind of take it in, and then you can copy it down, pause the video and just copy what we've got, okay? All right, so let's get started. Electron configuration. So first of all, electrons orbit the nucleus, but they have different shaped orbitals. Okay, so in real life, they've got orbitals that are spherical, they've got orbitals that have like other types of shapes. An s orbital is the spherical one. There's p orbitals. There are also d orbitals and f orbitals that are super complicated. Okay, however, when we are drawing an atom, we're just going to show it looking like a little bullseye or a target, and we're going to represent our atom that way. Now, I need you guys to copy this into your notes because you need to know that there are different sections of the periodic table. Okay, so pause this and copy it down. The main thing that I'm going to point out is on that worksheet that I gave you, it's more of a graphic organizer. It says that there are 4 blocks of the periodic table, S, P, D, and F. That's really important. Okay, so you should have already copied that down because you paused it. Okay, and then there's going to be 3 ways to represent an electron's address. We're going to think of it kind of like giving some turn-by-turn directions to get to an element. That's how we're going to do our configuration. 3 different ways. The first way, and this is what we're going to start with in the next lesson, I'm just previewing how to set up your periodic table, would be the electron configuration. And then the second way is an orbital diagram. It's just kind of a little bit of number 1 in more depth. Number 3 is the noble gas configuration, which is a shortcut. And then we're also going to look at the noble gas configuration and talk about those valence electrons. We'll get there. Okay, so you don't necessarily have to copy this down, but this is kind of a checklist of where we're headed in this unit. There's also a 4th way. We've kind of cut this out of the curriculum, but there's something called quantum numbers. If you're interested in that, go look it up. It's kind of mathy. It's not that bad, but it's detailed enough to where we're not going to spend a lot of time on that. Okay, so you have your periodic table. Get that out. We're going to mark it up. I need to change colors really quickly because we have all of our elements, and I want you to notice there's different sections. You are not going to color all of these blocks, so don't do that. But we have the S block, the P block, the D block, the F block, and I want you to notice helium. Look at helium. What is it doing? Like, it's just not connected. It's kind of weird. So what we're going to do, just for electron configuration purposes, we're not going to completely block this out, but we're going to make an X and we're going to move helium. Okay? It said helium was S2. That's where we're going to move it over here. So I'm going to draw a square, fill this in, and I'm going to write HE where helium is supposed to be if it were with the S block. And I'm going to put S2 above it because each of the blocks have like the letter of the block, plus these are numbered for the columns. That's going to come in handy in just a minute. So all we did just now is move helium. Next thing we need to do, if this is going to be turn-by-turn directions, what we're going to be doing is we're going to need coordinates. It's kind of like if you've ever played Battleship. You have to know like the column and the row to like sink a battleship or sink some kind of whatever, a destroyer, whatever in the game. So we need coordinates. So our columns already have headings, but we need to number the rows. Okay, so to number the rows, I'm going to do that in a different color just so it stands out. And then we're just going to number 1 through 7. Okay, so 1, 2, 3, 4, 5, 6, 7. We're going to leave this alone down here. Now I want you to notice, I did this in red. You can do this in any color. You can use a pencil, a pen, whatever, okay? But you want to get a highlighter or some different colored pens or something on hand for in just a moment, okay? Now because we have this section way over here, and it on your paper it might be difficult to determine what row you're on, let's go ahead and number these also. Now the first row stops at helium, so we're just going to start here at 2. That's part of the second row. And then 3, 4, 5, 6. We don't have a 7th row. Okay, so all we've done is move helium and number our rows. Okay? Alright. So before we get any further, I want y'all just to know that to write an electron configuration, we're going to have to get to a certain element. And to get to that element, we are going to start at element number 1, and we're going to go through each little section, that's going to be the little rows and the little blocks, until we reach our element. So we need to follow the same order as the atomic number sequence. Anytime we have to make a stop, we're going to write down our coordinates, the row and then the column. So if you want to copy this down, you can put this in your notes, okay? But we need to add something else to this periodic table before we're ready to do an example. Now I want to warn you, this is really weird. You're not going to find this anywhere else except through me, because this is just something that I've used and I felt like it's a really easy way to teach this. People pick it up really fast. Even in college, people use this method because it's a lot easier than what their college professors give, and you just use a periodic table. You don't have to like memorize something. So there's another diagram that looks like a triangle that's going diagonally, and it's a little tricky. So to me, this is way more straightforward. Okay. Now, if we're given turn-by-turn directions, you got to have a starting point, right? You also have to have a stopping point. So for our starting point, what we need to do is, I'm going to use green because, you know, green for start. I'm going to use green, and we are going to need to put an arrow, okay, that says start, pointing at element number 1. If we're following atomic number sequence, it makes sense that we would always start at the atomic number of 1, which is hydrogen here. We also need to have stopping points. So this is where if you have something that's red or a pink highlighter or something that's just bright, I'm going to use red. I'm going to make little lines for where we need to stop. Now, if you think about this, this would make sense, because if you get to an end of a block and you're driving, you're going to find a stop sign. I'm not going to make a stop sign, but I'm going to make a line here at the end of this entire section, okay, and it's going to say stop. That way, if you come back to this like tomorrow or Monday, depending on what day you're going to be doing the next lesson, it's going to tell you what you need to do in case you forgot. Because every day, you're going to forget a little bit of detail. At the end of the S section, we're going to stop. At the end of the D section, we're going to make another line. We're going to write stop. This would be kind of really hard to see, so I'm just going to make a line and then write stop there. It's just for that line. Okay, not for these numbers, but at the end of the D section. And at the end of the P section, I'm going to write stop. And then, not today, but another day, we're going to get down to this F section. So let's go ahead and make a line there and write stop there as well. Okay, so now we're ready to get started. So if you don't have this done, go ahead and pause the video, get your periodic table ready. So I'm going to move on with a couple of examples. Now, you're going to go over this again the next lesson, but I just want to preview how would we use this periodic table. So I'm going to do an example, and I do not want you to write on your periodic table past what we just did. Okay? So I'm going to need you to put your pens or pencils down and just watch. Okay? And then when you copy this, you're going to copy this into your notes, not anywhere on the periodic table. So again, put your pens or pencils down, and let's watch this example. Okay, so let's say I ask you to do the electron configuration for carbon. Okay, so I have to write on this so I can show you what we're doing. You are not going to write on this, but I have to show you how to use this as I'm doing the example. Again, you're not going to write on your periodic table. Now, carbon is right here, so I'm going to circle it because I want to see where our final stop is going to be. And then I'm going to write carbon right here with its atomic number and then an equal sign. And then I'm going to make my configuration. My configuration, again, is just going to be the coordinates for everywhere I have to make a stop. So, watch this. Don't write this down yet. I got to start over here at hydrogen. And so I'm starting here, and then my element's not in this section. I got to go to the line, and then it tells me to stop. So what do I do when I make a stop? I need to write down my row and my column. Those are my coordinates. So the first coordinate is going to be row 1, column S2. That 2 is a little exponent. And then I proceed to continue through the atomic number sequence until I get to carbon. Well, this is element number 2, so I continue through the next section, that's element 3 and 4. Oh, I got to another stop. So now I need to write down these coordinates. That's going to be 2, S2. Okay? And then I can't go down here because this is element number 11. Where does 5 start? Oh, it's right here. Okay. So I'm going to start here. Oh, and then there's my element. So I have to stop there. So now I write down these coordinates. That's why we wrote down the little rows here so we don't have to look way over there. This is still row 2 and this is column P2. Okay? So our electron configuration is 1s2, 2s2, 2p2. Some people prefer to make a comma after, whoops, we stopped there, so let me just undo that real quick. Some people will make a comma after they've made their stops along the way just to separate it out. I'm not going to count that wrong, but a college professor, an AP professor, or a teacher is not going to put those commas there, okay? So, electron configuration for carbon is 1s2, 2s2, 2p2. Why does this make sense? Well, I'll explain more detail once we get this down. However, I want you to know that this is foolproof. You are not likely to make mistakes with this as long as you know what your atomic number is. So see carbon's atomic number? It's given up here also. It's 6. So why is that significant? Well, because you can always make sure that you never miss this. Because if you'll look at your exponents, okay, 2, 2, 2, and you add those together, they're always going to equal your atomic number if you did it correctly. Okay? So it's foolproof. This unit, you're going to get probably the highest grade you've gotten on any of your tests, if you've struggled on any of them, and this will be one of the easiest units. Okay? It's as easy as that. So let's do another example. If you want, go ahead and pause this video, copy this down into your notes real quick, your notes, not your periodic table, and then let's do another example. It takes most people a couple of examples before this really makes a lot of sense, okay? So I'm going to do my next example. Oops. Okay. So we are going to do the element, let's see, which one are we going to do next? Let's do something a little further down. Let's do sulfur right here, okay? So that's element number 16. So sulfur is number 16. Well, I left these lines over here. Okay, so where do we start? We start at atomic number 1, okay? And our first stop, again, is going to be at row 1, column S2. So let's write that down. And then there's nothing else on that column, so we continue to the next numbers in the atomic number sequence. So our next stop is going to be, again, 2, S2. Okay, then we continue through the rest of the second row, and my next stop is going to be right here at this line, and that's going to be 2P6. Okay, that's the end of this row. That's element number 10. So element number 11 is going to be in the third section.